Density of water is 1 gram per centimeter cube or 1000 kilograms per meter cube. An object will sink in water or float in water depends upon its own density. If density of an object is greater than density of water, it is going to sink. And if an object's density is lesser than density of water, it is going to float. In case of boats or huge ships that take tons and tons of loads on them, they don't sink, they float, though their masses are more. Though huge ships' masses are more, their volumes are increased multiple times so that their overall density turns out to be less than density of water. So they float during when they are standing still or during their motion also. That is why ships are said to be in a dynamic equilibrium. In case of a ship, the ship will have its own center of gravity. Center of gravity is the location where the complete weight of the body is supposed to be centered at. Center of gravity works in a downward direction. And when the ship or a boat is placed in water, it displaces some amount of water. So that displaced water or displaced liquid will have a center of buoyancy. Center of buoyancy will be the centroid of the displaced liquid or water. So center of buoyancy works in upward direction. Now when a ship is placed in water, because its volume is more, it displaces huge amount of water. As a result, it experiences immense amount of buoyancy or upward thrust that makes the boat or ship to float. In case of a ship that is standing still, its center of gravity and center of buoyancy, though they work in opposite direction, they lie along the same straight line that keeps the ship standing still and floating in water. During turbulence, the ship either turns clockwise or anti-clockwise. As a result, the volume of water displaced by the ship changes, due to which the center of buoyancy also shifts. Now from the new center of buoyancy, as shown in this diagram B1, from there when we draw a vertical line, that vertical line intersects with the previous line joining center of gravity and center of buoyancy. That point of intersection is called metacenter. Metacenter is that point that decides that the ship is going to further tilt down or come to its stability. If a base of the floating body is heavy, then during an anti-clockwise tilt, the metacenter lies above the center of gravity of the floating body and the new center of buoyancy. As a result, the couple of forces acting due to the upward thrust and weight of the body works in clockwise direction, thus enabling the floating body to regain its original position. This state is called the stable equilibrium state. In case the floating body has a heavy top and lighter base, then during an anti-clockwise tilt, the metacenter slips between the center of gravity of the floating body and the new center of buoyancy. At this state, the forces due to the buoyant force and the weight of the body also work in anti-clockwise direction, overall making the ship to tilt down in water. This state is called unstable equilibrium state. If the mass distribution of this floating body is such that the metacenter coincides with the center of gravity, then the net force due to the upward thrust and weight of the body during any kind of tilt turns out to be zero. As a result, this body, the floating body, is said to be in a neutral equilibrium. And under neutral equilibrium, whatever be the kind of tilt, the body always regains its original position.